more people coming in. All right, so here are the two things you should have open. It is Big Ideas Packet and your mini final, your own personal copy, wherever it is you left off. And what I'm gonna do and how it's gonna work is I'll just ask you, and in the chat, y'all can feel free to just give me feedback on which ones y'all need the most support in. As we're working on this, you should be like editing your own mini final and then preparing to submit your copy. At the end of that, right, as our checkout, if you go to your pre-calculus Google Classroom, you probably have noticed I put this right here. That's going to be your checkout for today. So once you're done doing your revisions and you're ready for me to regrade your mini final, you have to do this thing right here. And if you check the instructions, there's video instructions. So just, once you have the chance and you're done, you're going to take a look at how to do this form right here. So yeah, that's going to just be at the end of the last 15 minutes or so. I'll have everyone do this. But if you need more time, then I'll see you all again tomorrow or Friday for more office hours, but we'll see. Hopefully we get a lot done though. All right. Let me go ahead and I'll be back at 1:15 so we could get started, everybody. All right, everybody, we're gonna soon get started. I'm just waiting for everyone to be here because, if it gets started and I have to re-explain some things, it will get a little messy. So welcome, everyone. Let me go ahead and put in our attendance. We decided to make this in a more organized, good, we're getting more people, in a more organized manner. So this is my tab. All right, Wednesday PM session. So who I see in the chat right now, I see Rebecca. All right, I see Brandon. I wonder if I could just add your last names later. I see Jalen. Jasmine. Who else we got? We have Rosario. And then Ruben. Let me know if I got everybody who's in my PM session right now. All right, so welcome everybody. So this is how it's gonna work. Let me just re-explain it. I know I explained it to those that were here, but more people came in, so I'm gonna just re-explain it. So there's two things you should have open right now. First off, you should have your big ideas packet open. Whether or not you annotated this before or not, like even if this is like new to you, like you never opened this assignment, just go ahead and open the big ideas packet. It's on our Google Classroom because I'm going to be referencing the big ideas from this unit. You should also have your own copy of the mini final open. So your own copy of the mini final, and we're going to look at this. And as I'm going over all the stuff in office hours, you want to also be editing and working on your mini final. And then, you could ask me to pause and things like that. At the end of this, before you leave, there is this form you want to make sure you turn in. Actually, everybody's doing this 100%, not just you all in here. Everyone needs to have this done, and there's video instructions on this. So basically, this is something you're going to be submitting next week when we're doing Illuminate testing. Hopefully your advisors went over that a little bit. Like next week in the morning, y'all are going to have CIA kind of testings, and then in the evening, you're going to be doing your POL presentations. Basically what this form is all you're going to do is you're going to be copying and pasting your answers to the mini final right on here. But the only difference with this document is it's the same old questions. The only difference is you have to actually type out reflection. So basically, what did you learn from engaging in the revision process? What do you understand now that you didn't before? Basically, what are your new thoughts after revising your work? And that's just going to be a quick reflection. And so that's at the end, though. We're admitting more people. Oh, yes, my bad. I can. Sorry about that. There we go. All right. For those that just came in, let me go ahead and add your names. I kind of went over the beginning of what we're going to do. One C2. Thank you. Thank you. All right, so you should have big ideas packet open, boom, and you should have mini final open. And lastly, before you leave, you're going to be doing this assignment, and this is true for everybody. It's on Google Classroom, and then there's even video instructions. If you missed what I said at the beginning, it's going to be right here. So, all right, let's go ahead and get started. So I'm here projecting the mini final, and what I'm going to do is I'm going to go question by question. So for example, I'm going to ask right now, who needs some support on question number 1? And this is open to everybody here. You're just going to use the chat. If you miss opportunity to ask for help, we're just going to move on to the next question. So for now, who needs help on number 1? And if I get no responses, I'll move on. Okay. I just have some wait time, and then I see that direct that personal message. Someone says they need help on 2A and 2B. Do we make a copy? Yep. You want to make a copy. That's the only way you can actually type into this mini final. That's correct. If we got advanced, do we need to do this? Nope, you do not at all. So if you're advanced, what you're going to be doing right now is working on your, either you're going with Carla. So right now, Carla has CSU catch-up session. If you're done with your CSU app, you're either going to work on your presentation of learning, or you're going to work on, what was the other thing? Or work on additional college work if you have it. So yes, you don't have to be here if you're already got advanced. Yeah. Um, but I do want to say this for the person who asked that, everybody does need to do this. So maybe you could at least take the time to do this portion. Even if you got advanced, everyone's going to do this assignment. And I think you're period 1. So it's on period 1 as well if you go right here. So just get this form in would be good to get it out the way. All right, cool. So, all right, so it looks like we're going to jump into problems 2A and 2B. So for this one, what's highly recommended is that you go to your group Desmos and see the equations that your group came up with, right? So does anyone else need some help on 2A or 2B though? I should know so that I can kind of just pull up who your group was. And y'all need to tell me so I could show you. Okay, good. So we have more than one person. All right, so and I know you messaged me privately, but I have to say your names. Me, I need to see my group. Yeah, so I could ask you whose group were you in. Okay, so Jalen. Jalen, I'm gonna start with you because you're the first one who said you need help. What group were you in again for Jalen? Whose group were you in? I mean,
Gabriel group.
Gabriel. Okay, so what you're gonna do for 2A is you're going to right now, if you could take a screenshot of this on your computer or phone or whatever it is, just take a screenshot. Let me know once you're done.
I got it.
All right. For 2B, you need a screenshot of this.
I got it.
Perfect. All right, next I'm gonna go down the list. Next we have, okay, Jasmine. Sorry, you're gonna have to remind me. Yeah, what group were you in, Jasmine?
I was with Sam, Danny, and Rosario.
Okay, so this one, Sam's group. Now, why does 1 point look off? 186, 3.87. Yeah,
We tried our best to graph it as best as possible, but it wouldn't.
but there's actually a typo right here. So this should be 68. There we go. See how it matches up? There was a typo in your groups. Yeah. Go ahead and take a screenshot of this for your group. Oh, I'm sorry. This is for 2B right here. This is 2B screenshot. And then let me know once it's okay to show you your 2A screenshot.
I'm done. I don't know if Jasmine is.
Oh, I'm sorry.
I'm
We're
also done.
two of you in the same group.
Yeah, we're both in 6th period together.
Okay.
Yeah, you're saying it right.
Okay, perfect. And then I'll need to show Brandon's as well. Okay, so let me go to your 2A portion. Here's the 2A that you want to take a screenshot of. All right. Let me know if you two are good with that 2A and 2B screenshots. And then I could show. Okay. All right. Then I could show for Brandon's group. Brandon, what group were you in?
I was with Gerardo.
Gerardo. All right. So let me make this organized. Let me first show you 2A. And maybe I'm going to zoom a little bit here. Oh my goodness, that's worse. Plus, but yeah, once I just get a better, it looks better when it's like more, there you go. Go ahead and take a screenshot of this. This is for 2A.
All right, I got it.
All right, and then this is the 2B.
All right, thank you.
Welcome. Okay, so I'm gonna just use probably this group's work just to guide everybody through this question on the mini final. So maybe I'm gonna make a copy for myself. So as I type on there, y'all can just see like, you know, example of how to get started on writing this. Okay, so step one. So I'm going to pretend that I'm part of Gerardo's group. Because we worked in a group, it's perfectly fine to use the screenshots. So for part one, we're skipping right now. Nobody needed help on part one. So we're on part two. So this is me pretending. Okay, step one is I'm going to first insert my screenshot. It says for 2A. We're going to only be looking at participants during phase one. Phase one, if you remember, that's the people that weren't using the Rapunzel hair serum. That means their hair was growing at a normal constant rate without that special serum helping it grow faster at a faster rate. So this is just phase one. So that's why we had to take two separate screenshots. So let me pretend I'm part of Gerardo's group. So I'm just going to go ahead and take my screenshot. And I'm going to insert that as evidence into my mini final. So insert. Usually mines are in my desktop. And it might look, yeah, doesn't look too bad. So there's my evidence, and I need to type around it. So I'm going to kind of do this. There we go. Or I could type below it. So here's what you're going to do. It says, based on their model and data, construct an expression for the hair growth rate as a function of time. Well, your function is the thing that's right here, right at the bottom of your, you know, on the side of the screenshot you all took. And oh, by the way, sorry, Rebecca, did I check in with you? What group were you part of? Sorry about that. I just want to make sure we all have our screenshots. Feel free to use the chat, just so I can make sure you got your stuff. Okay, it was you and Yaisa. And yes, you want to open the mini final on your own copy. If you have your Desmos, that's perfect, because then you could take your screenshots. So you and Yaisa, now where is that group? I don't see it on here. Oh, right here. Okay, so this one here, I think y'all were still working on this. So what I recommend for you, Rebecca, is because I think y'all didn't really get that far on your graphs. I think it's fine to just borrow somebody else's data. Otherwise, it's going to take you a bit to kind of like reconstruct this. So here, you could go ahead and borrow Gerardo's data, because I know your group didn't get that far in this, and take your screenshots. Because it's not really about the screenshots you have, it's the way that you're explaining it. So it's okay to borrow this here graph. Let me know once you've gotten this first one. This one right here, this screenshot is going to go for 2A, the one that looks straight like this. This is for phase one. This was for the first 84 days, if you could see on the table. Okay, thanks. And then here's your 2B. And then just let me know once you're done with that screenshot. Hey, Jorge, if you just came in, so we're working on the mini final, and right now we're getting our screenshots for 2A, 2B. Let me add your name to our attendance. Let me know if you need any clarification though, Jorge, that you just came in. All right, Rebecca, did you get the second screenshot? Okay, perfect. All right, so first off, everyone needs their screenshot, and I'm trying to model how we're gonna go ahead and insert our work. So everyone got the first 2A screenshot. You went ahead and inserted it. Now it's the time where you type out the expression. And then you're going to type out how did you get this expression too. So the expression, according to this graph, is going to be the part that says y equals ab to the x. Well, your a is right here. See, it says 1.5. Your b is 1. So if I'm in this group, I'm going to say the expression that models phase 1 is this. So you could type that out on your own, but I'm just going to write the function because I want you to make your own explanations. So a is 1.5 right here. My b is 1. And then it says it's to the x power. That's how I write my function. And then you're going to go ahead and describe how did you get this. So remember what you did in your group. How did your group kind of get this equation? So this part is what you want to add, everybody. Let me know if anyone has questions on 2A, but based on your own screenshot, right? I based this on the screenshot I seen, right? Based on your own screenshot, based on your group stuff, what was your function? Some of you, there might be some slight differences. It might not look like this. So let's see if anyone has any questions, clarifications.
My graph different than that, and I don't got a A and a B for the function thing.
What do you have instead? Let me see. So Jalen's group was Gabriel, right? Yeah, so actually your function, right, is already there for you. So it's literally y equals 1.57 for you. That's because some students used the exponential tool to find an equation, but this equation is actually equivalent to the one that's written right here. It's actually equivalent, yeah. 1.5 times 1 to the x power, because 1 to any power is just 1, so 1.5 times 1. But 1.57 is more accurate though. It hits more of your points. Let me know if that makes sense, Jalen, but your function is fine. It's right there for you. And let's see, questions. What are you, okay, so I got a question. What are we explaining? So you're trying to explain what did your group do to get this equation? So some of the groups were playing around with these sliders, like they were moving them up and down until it matched. So for example, this here slider, let me just pretend it's Gabriel's group. So for this group, it looks like they just created a Y slider only. And they kept moving this around until it was exactly right on top of the points. And the points that it would be right on top of it would be at 1.57. Now for this group, that makes sense because for the first 84 days, the hair growth rate was always 1.57. So it makes sense that the function here for this group, they got 1.57. So depends, right? For example, this other group, they used an exponential function. That's ab to the x power. They used a and a b slider. And again, they just played around with these sliders until it matched up with the point. So again, we could do the same thing. For this group, if you did exponential though, you had to make sure your B was 1. Because if your B is something, it's going to start to go up exponentially. So let me just put this back to where it was. So it depends on what your group did. You're going to go ahead and elaborate. Yeah, you add the photo with the explanation. That's correct. Sounds good. Let me know if there's any other questions for 2A. So yeah, you want your evidence photo, your function, and what did your group do to get this function? Whatever it is y'all did, or however you understand it now, you're going to go ahead and type that out. Cool. And then let me know who needs more time on this part, and then I'll wait. If we don't need more time, I'll go ahead and jump into 2B. So question is, what is y equals ab to the power of x called? That's called an exponential function. Let me put that in the chat. So if you used an exponential function with a and b sliders, then you're just going to go ahead and type that like this is what we did, and we just used a and b sliders until we matched it up to the points. That's fine. Or some of you, like Jalen's group, they just directly used a constant function, which is also okay. All right, cool. So if nobody needs more support here for number 2, let's jump to 2B. So 2B is very similar. Now it's just asking you to construct an expression for the hair growth of your participants during phase 2. So phase 2 is the screenshot where your graph goes up exponentially. So I'm going to take this out and I'm going to go ahead and insert my screenshot. So I think I was stealing whose group? I think I was taking Gerardo's group. I'm going to use his as an example. So I'm going to go to my next one. So all of you took your 2 screenshots because I made sure y'all did. I'm going to go ahead and take this screenshot. Then I'm going to go to my copy and I'm going to insert the photo. There's my photo. And then I guess I'll just type right below it. So for this one, it's again very similar, except this is not going to be constant at all because of course, after you start using the Rapunzel hair serum, your hair rate starts to increase exponentially. It starts to go up as opposed to staying straight like it did before you started using the Rapunzel hair serum. So here we go. Now we're going to go ahead and type out the equation. And for this example, I'm going to use the numbers in my screenshot. So for Shirley, this group used an exponential function. It makes sense to do that because the points are increasing over time. So my function is going to be, for this example, my A is 0.801. My B is 1.008. And I'm going to say that's to the x power. Then you're again gonna add your explanation. So the same thing. What did your group do to get that function? So I'm gonna just paste this down here. So right now you all are gonna do that for your own screenshots now. You're gonna type out your function that your group made. And what did your group do to get that? Because I remember when I was popping into groups, it was actually hard, right? A lot of you were struggling matching up the points with a function. Just try to add in there what you all did. How did you find this out? Because this is a pretty good one. This one, the points are literally almost this for Gerardo's group. So your groups might be different in what you got. All right, and again, I'm just giving wait time for y'all to put in your screenshots, write down your function, and add in what did your group do. Just giving some wait time on that. Let me know if anyone has any questions. If not, we'll transition into 3A. Question 3 is where most of the math and big ideas are at, just so you know. Question 1 and question 2 are all about you just analyzing the data you're given, modeling your data with a function. That's what questions 1 and 2 is, but the pre-calc stuff happens in question 3. All right, let me just give y'all one more minute on this, and if anyone needs more time, let me know, and then we're gonna jump into 3A. I'm also putting there, like for this, for advanced, if you're interested in still achieving that, because it's possible, but you can explain why this exponential makes sense. That's if you want to go for advanced. And for the prior one, you would want to explain why a constant makes sense, constant function. That's if you want to, you know, kind of make sense of your data. Why would it make sense here when the people aren't taking the Rapunzel hair serum, that their hair is growing at a constant rate and your graph is straight horizontal? And then why would it make sense that after they take this hair growth serum, the hair rate goes up, and why does it match up with an exponential? So that's if you want to go for advanced, just some tips there. Okay, let's move on to 3A. So for 3A, so let's just I'll read the question. So you're part of a marketing team, right? And you want to include like a before and after, so you could sell this Rapunzel hair serum for advertisement. You want to highlight the difference in hair growth, right, from before and after the study participants. And they need you to estimate the total hair growth that occurred first during phase 1 without the Rapunzel hair serum, and then phase 2 when they started using it. So what they're asking you to do is, this is phase 1 when they're not using Rapunzel. You're going to estimate the total hair growth of the participants. Then you're going to find out the total hair growth for the participants for phase 2. So these are what they're referencing. So we're using the same graphs as models for questions 3A and B. So, all right. So for 3A, it says estimate the total amount of hair in milliliters that occurs during phase 1 of the study. That's between 0 and 84 days. How confident are you about the accuracy of your estimate? So again, let me remind you that for the phase 1, so all your data tables are coming from here, by the way. So for phase 1, the first 84 days, the hair growth rate is constant. And I keep saying rate because it's important. These numbers right here don't represent hair length, right? A lot of people think the hair wasn't growing at all until they started taking the serum. That's not true. This is saying your hair is growing just at a constant rate of 1.57 milliliters per day. So it's constantly growing here, but after you take the serum, the rate goes up. So that's what this means. Okay, let me undo that just to kind of explain the table. Okay, so let's do this. So we want to find out the total hair growth in phase 1. So I'm just going to go borrow a Desmos again so I could visually show. And yes, for your part, you either want to draw a picture of this, right, on the paper and then take a screenshot and insert it as a picture, because what you want to do at this point is you need to draw and sketch. So maybe you want to have a piece of paper out and open with you. Sorry, someone disappeared when I'm like, you gotta draw and sketch. I don't know who just left our room. Okay. But yeah, that's what you gotta do for at least proficient here. So let me just zoom in right here. so I can get a better glance at this. So this is phase one. This is when your growth rate is constant. Let me go get one. Yeah, perfect. So if you need to get some paper and stuff to do a sketch of this, go ahead, take some time, get some paper. As y'all are getting your paper to do a sketch of this, I'm going to start to kind of annotate my graph right here. And maybe you're going to do that on your paper. So again, we need to remind ourselves that what we're looking at right here are rates. These are rates. And then this is when I'm going to start to use my big ideas packet. So after we like kind of investigated the data, now it's the time to apply our knowledge. So these are rates specifically, these are all millimeters per day. Hair growing at millimeters per day. I think we did that in the group with you. Is it okay if I have that picture for 2A and 3A? It depends. How about just share me on the document for that specific person? Oh yeah, if you were here earlier with me, yeah, we did this already. So you definitely do want to have the visual of how you're finding area and things like that. Or you could just share me on your what you did on your assignment. Let me just write you a message. Oh, sorry. That was not for everybody. My bad. Yeah, so this is where we left off at my last office hour. So we just went over 2A and 2B. And by the way, if you are finished, do make sure before you exit, what you got to do is this right here. The answers plus reflection form. Again, everyone's going to do it. The instructions are right here as a video. Oh, okay, no, you just need to put more work and explain it. Then fine, that's cool. You could go ahead and add to that as you're looking at the explanation again. That's perfectly fine. All right, so here we go, y'all. So we're looking at a rate graph right here. So this straight line represents rate. And what that means for our graph right here is the y-axis is representing the rate. Specifically, this point right here is representing the y value is representing the rate. So 1.57 milliliters per day. Millimeters. Kind of sounds like a liter, like a liquid. Millimeters per day. And then of course on your x-axis you have the number of days of the trial. The first phase ended at 84 days. So here's our 84. Okay, so we're looking at a rate graph right here. So we have a rate graph and we want to figure out total length of hair that grew, right? That's our goal here because we're going to compare the length of hair that grew in phase one, compare it with phase two. So this is where I'm going to be taking a look at my big ideas packet. Yeah. Yeah, I don't know if about the question. Let me know what you mean. But so I'm going to look at my big ideas packet and I'm going to see where I see rate because I know I'm dealing with a rate graph. And as you all are editing your answers, you should be referencing the big ideas because that's how you get proficient on this. So immediately I noticed big idea 2 and 3 have mentionings about rate. So I'm going to check big idea 2 first. All right, so big idea 2 says rate times time equals accumulated unit. And then I'm just going to jump down to the example. So what do you mean by rate times time equals accumulation? Here's my example. For example, 5 miles per hour times 10 hours. If we multiply these two together, hours cancel out and you get 50 miles. So rate right here, it's a rate times time gives me the thing that's getting accumulated. In this case, it's miles. There's other examples down here. If I have people per year times years, years cancel out, you get people. Inches per month times month, you get inches because months cancel out, and so forth. Okay, so far I don't know how I could use this big idea yet. So I'm gonna move on to big idea number 3. You will use big idea number 2, but just saying. Okay, big idea number 3. Let's see. Okay, first, when I look here, I noticed that this pay rate graph example that we did in class is a straight horizontal line. It looks very similar to our straight horizontal line right here. And they're both rate graphs. So I'm like, maybe it's more related to this one. So I look here and let's see what's happening. So I see some shading happening and I see some calculations right here. And its relation to something getting accumulated. Okay, so let's read it. Rate graphs are related to accumulation graphs because the area under a rate graph equals the accumulated unit. So in this pay rate graph that we did in class, the area under my pay rate, so the area under $13 an hour, after 2 hours, all I had to do was find the area. So 13 times 2 gives me that I make $26 in that pay rate graph. So how do I kind of apply that here? So I have a rate graph here and I want to find out how much hair grows. What should I do? Just referencing that big idea. And this is open to all who are participating here, all who need help on this. So I know that the area under a pay rate graph and this big idea right here give me total dollars. And I know that the area under rate graph gives me the thing that's getting accumulated or added up. What should I do here that we have this hair rate graph? Let's hear some ideas because I don't know if y'all are still thinking about this. So what can I do given that I have this straight horizontal rate graph, and how can I apply specifically big idea number 3? What happened in big idea number 3? If you look at your own copy, what should I do next? What is something I could do with a rate graph?
Do we calculate the area?
Yeah, and why do you say should we calculate the area?
What was that?
Yeah, so why do you think we should calculate the area? You're right. I just want to know, why do you think so? That's correct. We're going to be calculating the area under this rate graph, but what made you answer that?
I was reading the example right now.
Awesome. Yeah, that's what we're going to do. Perfect. Yeah, this is exactly what this big idea is actually telling us to do. It's basically, if you have a rate graph, and you find the area under the rate graph, it's going to tell you what's getting accumulated. The thing that we want is total millimeters of hair, like the hair, how much millimeters it's growing. That's the accumulated unit in this problem. So yes, we're going to find the area under this rate graph, correct? Yay. All right, let's do that. So let me go ahead and shade the area under, and in your own pictures, right? You could shade it Oh yeah, perfect. Sorry. All right, let's do that. I'm going to shade the area under this graph, and for y'all, your own piece of paper, go ahead and start doing that too. Let me just, I'm going to have to thinly shade this. And again, remember, I'm going to stop after 84 days because, at 84 days, because phase 1 ends, after 84 days, and which is right here. Boom. All right, good. So I know that I need to find the area under this curve because big idea number 3, and you should be writing that in your explanation. So big idea number 3 tells us that the area under a rate graph is the thing we want accumulated. In this case, it's hair length. That's what we want in milliliters. It's just an important thing to take note of and also to explain as y'all are typing out your answers. All right, so let's go ahead and find the area then. All right, y'all. So any ideas on how I could find the area of this very long and thin looking rectangle? And this is open to all of us here who are needing the support. How do I find the area?
You would do that by doing base times height.
Perfect. All right. What's our base? Base is usually here on the x-axis. What is our base length? We're going to do base times height, just like Rosario suggested. Base times height equals area of rectangle. Let's see, let me just try to see if I could get more participants like Brandon, Jasmine, Miles, Ruben. Do you have any idea, or Rebecca, do you have any ideas on what's our base of this rectangle?
Wouldn't it be 80? No, 80 something.
80
84.
something. Yeah,
Yeah.
yeah. You got it, Jasmine. 84. Yeah, because that's when the first phase ends at 84 days. Perfect. Oops. Go ahead and write that down. So yeah, the base, 84 days. And make sure y'all are writing this on your own, like pieces of paper and so forth. Oops. All right. Can we get somebody else to tell me what is the height? It looks very small, but what's the height of this rectangle? So we got our base of the rectangle, 84.
Wouldn't it be 1?
1.
1.57.
Brandon says 1.57. Brandon, why is it 1.57 instead of 1? Was that Brandon?
Yeah, I'm reading. Because of what's called, because it keeps going, like it stays the same, like for every day. So it's like gonna be like 1.57 for each one, because
Yeah.
it doesn't change.
All right, yeah, that's it. So yes, our answer is 1.57. 1 was almost there though. It does look like it's 1, right? But you want to be like, look at your table and also look at this labeling here. So this constant line, as was mentioned, it's always 1.57. So our height here it's actually this, 1.57 millimeters per day. So don't forget your units. Okay, so now that we have our height and we have our base of our rectangle, let's find the area. So I'm going to do first the height times base, or you could do base times height, whatever works for you. So 1.57 milliliters per day. I'm keeping my units because you want to definitely see what cancels out here. Times my base is 84 days. All right, when I do this multiplication, everybody, what cancels out?
Days.
Yeah, the days. I heard two answer that. Awesome. The days cancel out. Can anyone tell me what is 1.57 times 84 though?
131.88.
Yeah, 131.88. And our units is going to be millimeters because that's the thing that didn't get canceled out. It's still here. And now I want to tell you which big idea we just used right now. So first off, step one, we had to first know that we had to find the area under this line. That was big idea number 3, right down here. So that's what you want to type out, and you want to write down why. Why are we using big idea 3, the area under rate? The next big idea right here, when you're multiplying rate times time and you get that the days canceled out, that's big idea number 2. So big idea number 2, let me just go back to it over here. That's the thing we kind of first looked at. Rate times time equals accumulated unit. This is talking about the thing that's getting canceled out, like in this example. For example, hours got canceled out right here and you got miles. So that's actually, we're using big idea number 2 when we're canceling out the days. So then let me just type that out. That's over the word. So we're using big idea number 2 because, or you could say because rate times time is our accumulated unit. And then talk about the days cancel out. And you're left over with millimeters. Yeah, I can't move it. Oops. Okay, I had to get rid of it because it was over my stuff. So as I'm just typing this out, y'all feel free to add to your own, drawings and stuff that you're gonna insert as your evidence to your own mini final. So big idea number 2, because rate times time is accumulated unit. In this case, millimeters is left over. All right, let's see if anyone has any questions. After, if there's no questions on this part, I'm going to show you like what are your evidences that you're submitting and what are the things you need to type out. I'm not going to type it out for you. That's the part where I want you to try to type out your own understanding and think about how big idea number 2 was used, how big idea number 3 was used, like in your own understanding. That's what you're going to type out. But let me give some time to see if anyone has questions on this. Oh, sorry. Can I text you when I'm done with the reflection? Yes, you can. Sorry about that. I just seen this message. Yes. Yeah, so you're free to, like, if you're done with that, you're free to, yeah. Yep, welcome. All right, cool. So if no one has any additional questions on how we just solved how much hair had grown in phase 1, this is what you do. So whatever you copy down your work on, you're going to either take a picture of it with your phone and insert that, or if you were doing a digital thing, you're going to do that. I'm just going to pretend that I'm a student, and let's say I did my work digitally like this. So I'm going to go ahead and put my work onto my mini final. So I'm going to go ahead and put it here. So it says insert work and justification. So I put in my picture. So that's my work. So I'm just modeling for you how, to insert your stuff here. Okay, so that's my work. And at the bottom, I have to add my justification. So in the justification, though, you have to explain what did you do and why, or what did we do and why? What big ideas did we use? And lastly, the other question was, how confident are you about the accuracy of your estimate? That's the last thing you want to make sure you answer. right here. So this is where you type out your own understanding that we've just done. Highlight that in yellow. So this is the work. I wonder if I could already delete my drawings so y'all can see that. I think so. I hope y'all got this down. Okay, there we go. So you're gonna insert your own copy of the work, and then your job is to now explain this. What did we do and why? What big ideas did we use? And then lastly, how confident are you about the 131.88 millimeters of hair that we decided was grown in phase 1? All right, I'll just pause to let y'all add your screenshots, take some time to do that, or add your photo from your phone if you were on paper. All right. Do y'all need more time, or do you think we should get, because it's 2:08, so we have about 22 minutes. And I will say 3B might take some time. So is it okay if maybe y'all can add to this, and then once you're ready, you could submit it, so that we could get on to 3B. Let me know what y'all prefer, or if there's nothing in the chat, we'll just head over to 3B. All right, everybody, let's do 3B. So just make sure you answer this part in yellow. So 3B says, now you're going to estimate the total amount of hair, milliliters again, right? Similar to how we found in 3A. But now this time it's between 84 and 168 days. That's phase 2 of the study. It says, how confident are you in the accuracy of your estimate? So phase 2, again, I could go up in my table. So the first 84 days was phase 1, and then the next 84 days is phase 2, which is down here. So phase 2 starts when 84 days ends, just so you know. So this part is the part of the graph that starts to go up exponentially. So I'm going to, again, go ahead and borrow somebody's graph. So I'm going to steal Gerardo's graph again. So we're now going to phase 2, and we need to try to estimate how much hair grew here. But now it's a problem. We don't have a nice straight line like before. So like, you know, how the big idea number 3, we had a nice straight line, and it's easy to find the area of it because it's a rectangle. But this time we have a curvy looking exponential function. So we need to now take a look at what other big idea can we use then to determine the area of this curvy rate graph, because now what do we do?
But we use big idea number 4.
Big idea number 4, geometric shapes to approximate area. Okay, yeah, because it's curvy. So yeah, I see some curvy graphs. It says you can use geometric shapes as a way to approximate areas under curvy rate graph to determine whatever's being accumulated. Okay, but there's this little last part. This method is not always practical. Okay.
I got the answer.
What was that?
Big idea number 6.
All right, big idea number 6. All right, so why do you think big idea number 6? It's correct.
Well, there's 2 different methods. There's the left one and the right one.
That's correct. Yeah. Awesome. And yes, it's going to be big idea number 6. Big idea number 5 would work too. Because you know how this prior big idea says this method is not always practical, right? If you look at big idea number 5, it says this is the formal method to estimate area under curve is to use Riemann sums. And it talks about what Riemann sums is. This is the process of drawing rectangles under your graph. Then you calculate the area of those. to make your estimation of the area under the curve. And then as y'all can see in this visual, the more rectangles, the even better your estimate, right? So less space left over or less space that's over the graph. And yes, big idea number 6 is the actual process, like the actual way to do it. So yes, because we have a curvy rate graph, and these are all rates again, we're looking at rates. We need to try to find the area under the curve. Because it's curvy, we're going to have to use the process of Riemann sums. So let's make sure that you write that down in your stuff. So we need Riemann sums, which is like AKA left or right Riemann, or just put rectangles. We need them because this graph is curvy and not horizontal. So we'll need to make like an estimate. And it's not going to be perfect. The estimate is just going to be an estimate, and we're just going to use the Fermat method. Okay. Another question is, does anyone know like why would we need to find the area under this rate graph to tell us our answer? Like what big idea would I be using when I'm doing that? I wonder if anyone knows. So why do we need Riemann sums? Basically, like why do we need the area is the question. So that's my question to y'all. Someone just asked, what big idea is this? Actually, it's multiple. This could be big idea 5. This could be big idea 6. This could even be not 7. This could even be big idea 8. And this could even be big idea 9, because big idea 9 talks about how to actually draw the rectangles. So any big idea that's mentioning the Riemann sums or drawing rectangles is going to be one you're going to talk about. So all of those are versions of it. Okay, so I'm assuming most people maybe are stuck on this question I put in the chat. Why do we need the area? And again, so what am I using when I'm determining, hey, I need the area of this? I'm actually still using the same big idea that I used before. I'm still using big idea number 3. I'm still using the fact that the area under the rate graph gives me accumulated unit. So we're still using the same thing, even if it's not perfect like this picture. Even though it's not like a straight line, we could still apply this big idea to this problem. So we're also still using big idea 2 here. So that's just as a note, we're still using the fact that area. So we are still using big idea 2. Because this is a rate graph. And the area under it gives us the accumulation, again, in this case, millimeters of hair. So just so to clarify, we're still using big idea number 2. Okay, so let's get on to doing some rectangles under this. So let me leave this up to you. First off, here's the 2 questions. And this one, I'm not going to move on until we get some answers. Should we do a left or right? Riemann. Left or right rectangles? Why? Or you could just say left or right. And if you don't know why, that's okay. So you could go back to your big ideas and take a look at what's the difference between left and right. Then go up here, left versus right here. So as you can see visually, the left one on this graph kind of gives you an underestimate. The right Riemann on this graph gives you an over because it's going above the line. So what do y'all think we should do for ours? So I have one suggestion right now in the chat. They said to use the left. For the person who said left, do you want to like give us a small reason why it's better to use left for this one? Because it's under. Okay. And I think like because it's under the curve rather than going over is what it's meant. Okay, that's totally fine. So let's use a left Riemann. I'm totally not against it. You could use either left or right, so we're gonna do left. Now let me ask you guys, how many rectangles should we do? It's up to us how much we want. How many rectangles should we draw? That's for everybody. All right, I have a suggestion of using 3. Any other suggestions? Oh, okay, so 3 because there's 3 points. That's actually a good reason. Anyone do you agree or disagree with using 3? You can put, okay, just put agree if you agree. If not, just put disagree. Just put that so I can see who's with us here. All right, so for our 3 versus not 3, go ahead and put that in the chat. Unless you were here earlier in the earlier session, our earlier session used a different number. So Jasmine, Miles, Rosario, and Ruben agree or disagree on using 3 rectangles. Just go ahead and put that in the chat if you agree or not. All right, so let's see. I have one thing. Technically, wouldn't it be the more rectangle, the better the estimate? Yep, that's true. So someone said, wouldn't that be technically the more rectangle, the better the estimate? Yeah, because that's big idea number. Let's see which one had that big idea. More rectangles, the better. Where is that? Oh yeah, big idea number 8 says, the more rectangles we create, the better your approximation. So notice here they use 4. There's a lot of white space under your curve. But notice as you use more and more rectangles, that blank space under the curve gets more and more filled up, so you get a more accurate representation. So that's true. But let's say that you cannot do like 10 or 20 rectangles. If you go to your mini final, that's where you're going to answer this part where it says down here, I know it's hard to see, how confident are you in the accuracy of your estimate? That's when you're going to say, if you used a little bit of rectangles, you're going to say, I'm not that confident because it's not going to be a good estimation. Then you could talk about what would you do differently if you wanted something better. So yes, that's just to answer that question, is it more better? Okay, since most of us are agreeing, let's agree to do 3. Let's agree to do 3. But yes, if we're doing 3, then we know, according to the big ideas, using 3 is a little bit of rectangles. It's not a good estimate, but we're still going to use it, and we could just address it when we talk about if the accuracy is good. All right, thank you those for agreeing. Let's do it then. Okay, first things first. So remember, phase 2 starts at 84 days. Okay, so I have to find 84, and we're going to be using a left Riemann. Okay, sorry. I had to pop out. Hey, what happened to Jalen? Okay, anyways. So let's go, everybody. So let me find 84. Sorry. It's because I have to trace my graph or I won't see it. So 84, that's kind of tricky. It's right here. And it's hard because I can't, the points don't pop up when I'm using this drawing tool. See, I can't see now. Yes, I do think you want to create your own sketch. Yeah, create your own sketch. So yes, that's a good question. It should be fairly easy though. Here are the points, like in case y'all are like doing the sketch on paper. So there's this point. You want to maybe copy it down. It's 100 and, sorry, it's not that. Wait. Yeah, I guess it is. It's hard because it kind of keeps moving. It's about this much. I'm gonna hit the points. trying to hit on 140. 140 is comma 2.444. And then 168 is, has to be perfectly 3.055. Let me know if anyone needs me to go over that again. So 112 is 1 point, it was a 112? Yeah, 112 is 1.955. 140 is 2.444. Then the last point is, I have to go right on 168. 168 is 3.055. Yeah. So when you're doing this sketch, wait, go back to the first one. Yes. It's 112 comma 1.955. Welcome. All right. So the problem is I gotta make sure I start at 84 because that's when phase 2 started of the experiment. And it's right here. So I need to remember where to draw my line. Okay, I hope I remember. I'm very, very forgetful. So let's do this. Oh my gosh. Was it right here?
Yeah, it was right there.
Oh my gosh, thank you. Okay, so that's my first one. And I just want to at least hit that so that y'all can see what the point would be. Well, it was about, yeah, it's about. So go ahead and also write down this one. So 84 comma, because that's where we have to start. So write down this point as well in your graph. So 84 comma 1.564. And then of course our ending point is when x is 168. So let me know if anyone needs to see this one again. And this is 168 right here. So essentially our goal right now is we're going to be using Riemann sums so we can find the area under this rate graph. And the area is, let me just shade this portion. You know what I mean? But of course, when we draw our rectangles, it's not going to be perfect because of course we're only using 3 and we're either going to get a very big underestimate or a very big overestimate. Again, depends, but I think because we're using left, we're going to get an underestimate of the area. Okay, so that's our goal. We want to find that exact area. Okay, before we get started on creating our rectangles, this is what we need to do. First off, I need to know the length of this here base of this image that I have. So the base is basically going to be, I know that my point ends right here on the x-axis at 168, because that's the point that ends over here. And I know it begins at 84. And what I'm doing right now is I'm trying to make sure I create evenly spaced rectangles. So in order to do that, what I'm going to do is I'm going to do 168 minus 84. This is my kind of some scratch work. And when you do that math in your calculator or phone, you should get 84. So it's just, it makes sense because the experiment was 84 days, 84 days. Okay, cool. But now if I want to create 3 evenly spaced rectangles, I have to take this number and divide it by 3. The length divided by 3. Y'all can do some of that math on your own to double check, but 84 divided by 3. Yay, I actually thought this was going to be a decimal. So 28, not bad. It's 28. So what that means is the base length of each rectangle is going to be 28. Okay, so y'all said, so this point right here should match up. So 84 plus 28 should give us this point, I hope. Let's see. What's 84 plus 28? Wait, sorry. The first number says 118. I'm confused. So the first number, no, the first number said, the first number was at 84 and then 1.564, if that's what you mean, the first coordinate point. Oh, you were asking this. No, I'm sorry. This is my horrible handwriting. This is 168 minus 84. So I took 168, the end, minus the beginning. 168 minus 84, that gives me just 84. And because we wanted 3 rectangles, I divided by 3 to get 28. So that's what happened there, my bad. Okay, and then someone says 112. So when I do 84 plus 28, I get 112. So let's hope that's this. Yeah, yay. So it's gonna be easy for me to draw the left rectangle because it's right there. I don't have to click. All right, so here's my space for it. And because this is a left endpoint rectangle, that means that I need to look at my left column, not my right column. See, this is my left side. And I'm gonna draw my rectangle like so. So that kind of like could erase this part. Let me just draw that better. Like that. And see how the upper left-hand corner is touching my graph. And the base width, I did 84 plus 28. So the width should be 28 because we wanted 3. So the left, the next left Riemann is going to be, because this right here ended up at 112. Let me write that down. This point was 112. We're going to do 112 plus 28 again to get the next point. And of course, it should end up here. So 112 plus 28 is 140. So let me just double check if that point is 140. Yep, so that's going to be nice. And then we're going to go ahead and draw our left Riemann. So this right here is where 140 is at. Notice how I'm not going all the way up because I know a left Riemann sum is going to touch right here, and then I'm going to draw my rectangle. That's why I didn't go all the way up here. This one does go all the way up because it's a left, so the upper left-hand corner is touching my graph. And I go ahead and draw my rectangle. That's my second one. And y'all can already see the last one's almost there. We just got to connect the dots. So there and there. And you can ignore this part or just delete it. That's not going to be part of it. Just going to make sure I draw the line down here. There we go. All right, so there is our 3 left Riemann sums. You're going to go ahead and make sure you copy this on your paper. And then we're going to go ahead and we need to find the area of this. And when you do your explanations, you want to make sure you explain that this is going to be an underestimate, because notice how these portions aren't taken into account. They look like kind of triangles that we're still not adding up those areas of. And then when you do your explanation, just talk about that. All right, I'm gonna quickly go ahead and jump into the area. We are out of time, but you're free to stay here so we can finish this problem. Okay, finding the area. So from 2A, we know to find the area of a rectangle, you do base times height. So we're gonna do the same thing, but for each rectangle here. It's nice that we made sure each base was 28, because that means all I gotta do is the base, 28, times my height, whatever that height is. So it's going to be 28 times, and this height is, I forgot what it was already. The height is going to be the y value, by the way. So at 84, 85, no, it was 84. 84, it was 1.564. So can someone in the chat, can someone do 28 times 1.564 and tell us what you get, and that's going to be our area. So 28 times 1.564. I have to hold the point. I lose it when I do some work. I don't know if anyone's saying anything.
I got 43.792.
43.792. Write that down. 43.792. And then, so this 28 is just the base, by the way. And then when we do that, by the way, I just want to clarify this area that we got is going to just be millimeters because we did 28 days for that rectangle. We did 28 days times the rate. And in this case, again, the rate was 1 point something. 1.564. 64. And the Y here, remember, represents rate. So this was millimeters per day. So basically the area of that little rectangle there cancels out days. It's going to give you the millimeters of hair. And that's the Y of that. So again, we're going to get the total hair growth in this phase 2 of the experiment. Okay, then we just got to keep going. So that's just the Y again. This is again applying big idea number 2. When you do rate times time, days cancel out, you get your millimeters. Let's keep it going. Oh yeah, and thank you. Thank you as well. Somebody else helped with they got the same area. Thank you. All right, let's keep going. Yeah, and it would be so helpful if y'all just if you verbally shout out the answer so that we can. It's hard for me to go to the chat because then I lose the tool. So for this one again, the base is going to be 28. So it's going to be 28 times whatever the Y value is here. 1.955. So what's 28 times 1.955?
54.74.
Whoa, what was that? 54.74.
74.
Okay, so two of you had that at the same time. Thank you so much. 54.84. And then again,
74.
dang it. Okay, 74. Oh no. I'm just gonna write over that because I'm gonna delete my thing. So 74. Oh my gosh. That's a 7. Okay, so 54.74 millimeters. And then we're gonna do the last one. So it's gonna be 28 times, what's that again? Times 2.444. So 28 times 2.444. What do we get there?
6,832.
What was that?
6,832.
6,000. So that seems quite large.
I got something different. I got 68.432.
68.432. I wonder if that's what you meant too, though, Rebecca. Or what did you multiply to get that? 68.842. I'll just do 0.8 if that's nice. I mean, just to round it off a bit. Let me know what you multiply, Rebecca, because or I don't know if you just missed the decimal. It should be 28 times 2.444 to get hopefully 68.8 millimeters. Okay, so last thing we're gonna do is let's add these all up. Oh, okay. Let's add these all up. And what do we get when we add up all these areas? And that's going to give us our estimation. Again, this is an underestimate because we still are missing these, right? You're just going to talk about how this is not precise in your answer, though. That's where you drop your explanation. But let's find out the total area here. Let me know once someone's ready. All right, what do we get when we add these all up? I don't know if y'all got to it. Let's see in the chat here, 168.332. Do we all get that? 168 point, I'll just say 0.3. If you add these all up, millimeters. Oh, I'm sorry, 167. Wow, come on. I'm getting a little bit of yeah, I sometimes switch my numbers around. So this 167.3 millimeters, is that what we got for the rest of us here?
Yeah, that's what you got me.
All right, perfect. All right, so great. Here's our answer. Here's our work. Now it's time for you all to take pause, take a picture of your work, or take a screenshot if you were somehow did this on a PDF or whatever. But I'm gonna model for you what we do next. So okay, I'm gonna take my screenshot of my work, and that's gonna be my evidence. Then I'm gonna go over to B, and I'm gonna insert screenshot. Then we have to explain. So I'm gonna go ahead and clear my drawing right here. There we go. There's my screenshot, and at the bottom, very similar to what we did at the top. It won't let me oh, that's why. Oops. Okay, I'm just gonna do this. There we go. All right, so now is the time to actually add our explanation. That's the important part. So similar to this, same thing. What did we do and why? So remember, why did we decide to use Riemann sums? The first thing, remember, like the first suggestion was to use the big idea that talked about geometric shapes, but then we decided not to, because if we read further about that, it says this isn't like a good, it's not really a precise method. And then we had to move on to the big ideas that talked about Riemann sums. So you want to type that out. The whys, also what big ideas did we apply? I did mention a lot of big ideas, but you all are going to be open to choosing which ones you felt correlated more. Then lastly, how confident are you in your estimate? So again, remember, because we didn't fully calculate the full area, we still have these chunks we didn't take into account of. You're going to say it's not accurate, right? And then maybe you could go on to tell us, how would you make this more accurate? Maybe you're going to talk about big idea number 9, where you could talk about how, according to big idea number 9, or sorry, number 8, where we talked about how the more rectangles, the better. But, you know, who has the time to do that? There's also this Desmos calculator. Remember, I kind of showed the group this. Someone can even virtually use this if you put your function in there. But yeah, that's just an option if anyone wants to go for advanced on that part. But yeah, so let me know, does anyone have any question on this one here on 3B, any last minute kind of questions? And if you don't, for part C, it's straightforward. So now that you have your results, right? Our result so far was that in phase 1, without the hair serum, the participants grew 138.8 millimeters of hair. But then when they used this magical hair serum, they grew a total of 168.3 millimeters of hair length. So there is a big difference, right? So you're going to write a sentence or two that makes the results of the experiments, and you're going to make a claim about it and about what this hair growth serum can do for you. And the marketing team is going to use any of your data to make a label for the serum. So this is like you pretending to be a marketing manager. You're going to go ahead and tell us the findings and like whether you would promote this product or not if somebody wants to grow their hair longer. So C is kind of straightforward. It's basically based on A and B here. Let me know if anyone has any questions. But I very much look forward to seeing y'all type up your explanations and how y'all understood this and your pictures and all that. All right. If we don't have any questions, I don't want to keep you all more. We're already 12 minutes over. Feel free to remember though, once you're done, you could share me your mini final so I could regrade it. Or you could resubmit it, whichever one. And you do not want to forget about this right here. So because we're over time, you could go ahead and do this like on your own time today, but everyone's going to be having to do this. Again, the instructions for this are on Google Classroom. If you click on it, there's YouTube directions on it. I could also check in with everybody tomorrow who was here. I'll send you a text maybe to remind you on this. But again, once you're done with the mini final, please share me as well so I could regrade it, give you some credit. All right, everybody. Y'all have a great day. Thank you so much for being here. Tomorrow, if you want more pre-calc help, it's going to be in the afternoon. So in the morning, you're going to have AP Calc, afternoon for tomorrow pre-calc. All right, y'all. Bye, everybody. Bye, y'all. This was a great session.
Bye, Miss Adana.
Bye.